Hi, welcome to another lesson at EDU Solutions Institute. Now, today we're continuing on our CSEC physics syllabus on the topic of momentum. So last week we looked at the principle of momentum, the definition of momentum, the formula that we use to calculate momentum being mass times velocity. Now, this week's lesson, we're going to put all those in practice and look at these questions to explore more on our principle of momentum. So stay tuned as we explore these questions together. So let's get into it. So we have a table for the first collision has been provided for you. Now, we have before collision, we have that there is this small 2 kilogram ball moving to the right, 5.2 meters per second, collide with a stationary 13 kilogram ball. So that's before collision. Now, after collision, they both stick together and they move off with a velocity v. Now, based on this and based on last week's lesson, we know that this is an inelastic collision. Why? Because they're sticking together at a point in motion. So the question now is to fill out this table with momentum before and after for each ball and then the total. So for the first ball, it would be mass times velocity. All right. Now the mass of the first ball is 2 times its velocity of 5.2. So hence we get 10.4 and the unit would be kilogram meters per second. All right. And then after collision, we're going to leave that. So let's do before collision for the second ball. It's also mass times velocity. In this case, the mass is 13 and the velocity is 0 because it's not moving. So that is 0 kilogram meters per second. So therefore, the total momentum before would be just the 10.4 kilogram meters per second. Right? So what we know is that after collision, the total will always have to be 10.4 for this case. But in this case, let's examine what's the momentum before or after collision for the two. So it would be mass times velocity, right? Now, in this case, we don't know what the velocity is. So how can we find the velocity? Is that we know that before collision, the total momentum is 10.4. Then after collision, it would be 13 plus 2, which is the masses, times the velocity. So that would be 15v, 10.4, we divide by 15. So therefore, the velocity here would be 10.4 divided by 15, 0.69. So therefore, this mass of the first ball would be 2 times 0.69, which gives us 1.34 kilogram meters per second. And we do the same for after collision for the next ball, which is 13 times 0.69, which would be 8.997 kilogram meters per second. So therefore, if we add 8.97 plus 1.34, we get 10.31, which is relatively close to the 10.4, and that's because we have rounded off the velocity as well as the first ball after momentum. All right, so let's look at the question. So now this here asks us to find the momentum after, the velocity after, which we did up here. So we're going to go to question 3 now. Alright, we're not going to create the table. What we're going to do is just to find the unknown for these questions, which would be the velocity of this object here. Right? So based on this situation, we know this is an elastic collision, and that's because they are separate in motion. So we're going to have that momentum before collision equals to momentum after collision. And before collision, we had, let's call this 1 and 2, 1 and 2. So it had the mass of 1 times the velocity 1 plus the mass of 2 times the velocity 2 equals to the mass of 1 times its velocity that we need to find v prime plus the mass of 2 times its velocity. All right, so therefore, this would be 10 times 6 plus 3 times 3 equals to 10 times v prime plus 3 times 9. All right, so this is 60 plus 9 equals to 10 v prime plus 27. So this is 69, we take over the 27, so it becomes negative 27 equals to 10 v prime. Okay. So we continue. This would be 42 equals to 10 v prime. We divide by 10. So therefore, v prime is equal to 4.2 meters per second. All right. So as you can see, we utilize the principle of momentum to say that the total momentum before will equal to the total momentum after, and then we use that principle to find the unknown velocity there. All right, let's look at the second of these questions. All right, so therefore this one still elastic collision because they're separate in their motion. So again, we start by saying momentum before equals to momentum after. Again, we're going to call this 1, we're going to call this 2, this is 1, and that's 2. So it will be mass of 1 times velocity of 1 plus mass of 2 times velocity of 2. Right? But if you notice, velocity of 2 is going to the left. And remember, going to the left means we have a negative direction. So therefore, it would be a negative v2 in that case. And that's equal to the mass of m1. And m1 velocity is also going to the left. So that's a negative v prime plus m2 is going to the right. So that's a positive v. So we substitute, this would be 3 times 3 plus 2 times negative 2 equals to 3 times negative v prime plus 2 times 4. So this becomes 9 plus negative 4 equals to negative 3v prime plus 8. So 9 minus 4, we get 5, and we take the 8 over, so it becomes negative 8 equals negative 3v prime. So this is negative 3 equals negative 3v prime. We divide by negative 3 on both sides. We get v prime in this case would be 1 meters per second. Now, we see here that we have to utilize the direction because momentum is a vector quantity. So hence direction is very important in our calculations. So once something is going to the left, we have to indicate by using the negative sign. So here we have the negative for this situation, And then we have the negative here because this is going to the left as well. All right, then we go to our final question. All right, and again, this is a elastic because they're both moving independent of each other. All right, so again, we will go with momentum before will be equal to momentum after. All right, and again, we're going to do this is 1, 2, 1, 2. So it's mass of 1 times velocity of 1 going to the right, plus mass of 2 times velocity of 2 also going to the right, equals to mass of 1 times velocity, which is going to the right, plus mass of 2 times v prime, also going to the right. So everything is a positive because they're going to the right. So we substitute 3 times 6 plus 5 times 4 equals to 3 times 3.5 plus 5 times v prime. So 3 6 is 18 plus 20 equals to 10.5 plus 5v prime. So this is 38. We take over the 10.5, it becomes negative 10.5 equals 5v prime. So this now becomes 27.5 equals to 5v prime. We divide by 5. Therefore, b prime is 5.5. Right, so v prime becomes 5.5 meters per second. And again, we see that we will always use the principle of momentum to calculate our unknown quantities. Now, that's the end of today's lesson because momentum is basically a repetition once we understand the principle to be applied. All right, so that's it for us this week, guys. Hope you understand. If there's any questions, just let me know in the comment section so I can give some more clarity. Or if you have a question that you like me to try, you can always go ahead and give me that question in the chat, or you can email me at everythingphysics2020@gmail.com or edusolutions@gmail.com. So stay tuned as we explore more on our CSEC physics syllabus. See you next week.